All right, so you see this polar paper, but what polar coordinates basically are is they are measuring points away from the origin, or like the origin, that's where the polar coordinates come from. You can think of this like even as like a pole, and you're rotating around. Okay, so they'll call that the pole position, and that's just 0, 0. And what happens is the polar coordinates are not x and y anymore. They're r and theta. So what r represents is the distance away from 0, 0, and theta represents how far it's rotated. Okay, and so what would happen then, if I was looking at my polar paper, so I'm going to assume, oh gosh, let's see here, 1, 2, 3, 4, 5, 6, 7. Okay, so these are at 10-degree increments, it looks like. Hopefully you can see down the middle, the bolded is the xy axis. If I asked you to graph in polar mode the point 2, 50 degrees, what that means is I'd go out 2 units, 1, 2, and then I'd rotate it 50 degrees. So there's 10, 20, 30, 40, 50. So if I'm looking then, here's the 0, 0, or the polar position. If I went straight out, you can see that it's 1, 2 units away. So polar equations are circular, okay? Or polar coordinates today are circular. So I'm going to kind of just draw my path here. So I went 2 units this way, and then I rotated 50 degrees up. So that's how polar coordinates work. So if I was drawing this point right here, the point r, comma, theta, this distance right here would be r, and this distance would be theta. What does this look kind of like? This is why I was pointing out similar to some other things.
Oh.
Yeah, isn't r like the could be considered like the magnitude of a vector, and theta is like its direction angle. And so the way that we find out what x and y are is going to look familiar to you, because it's the same way that you find the component form of a vector. So if I wanted to find out what x was, so we'll call these conversions. If you had r and theta, and you wanted to convert to, we call these rectangular coordinates, because on the coordinate plane, we're basing straight distance, so left and right, like a rectangle. The way that I would figure out x is I would take r times cosine of theta, just like in the component form how we did magnitude times cosine of theta. And the way I would figure out y then is r times sine of theta. Okay, so that's if I have polar coordinates and I want to go to rectangular coordinates. Let's try to think back. What if I have x and y, and I want to figure out what r and theta, what the values of r and theta are? How do you think I'd do that? So, yeah, Pythagorean theorem. So r squared equals x squared plus y squared, right? Then you take the square root. And theta is the tan inverse of y over x And just remember that sometimes we need to add 180 if we're not in the right spot, just like before. Let's just check on our formula sheet that we have those things written down. Okay. So there's my conversions for x and y. And this I wrote tangent of theta equals y over x, so if we want to add just to make sure that we understand that means theta is tan inverse of y over x, we can add that in. We may need to add 180 degrees. Okay. So, I gave you this polar paper. I have some more polar paper too, if you want to, for your homework today. You can try to graph them on rectangular. You just kind of have to do like a little, okay, I'm going to go out this many and rotate it around, so it's a little bit of a guesstimate. But I'm going to give you some coordinates, and we're going to graph the coordinates, and then we're going to convert them. Okay, so we're going to graph the polar points 3 and then 5 pi 6. All right, and then after we graph that, we're going to then convert to rectangular coordinates. Okay. So I'll do a little sketch on here, but then let's use our polar paper. Just a reminder, think unit circle. 5 pi 6 is over here on the unit circle, so it's 30 degrees shy of 180. It's 150 degrees. Okay. So if I was trying to graph this path, that means I'd go out 3 and I'd rotate 5 pi 6. It's going to end up being somewhere over here. Okay, so out 3, if I'm like labeling, this is 3, and then this angle is 5 pi 6. So using our polar paper, just so we see how that works. So 5 pi 6, like I said, is 30 degrees shy of 180. So if I went out 1, 2, 3, and I rotated, let's see, this is 180, so I'm going to go back 30. And if I looked from the pole, see it's 1, 2, 3 units away. And it's rotated 5 pi 6 from that standard position. So in a second, when I give the rectangular coordinates, let's talk about the signs of those. The x is going to be what? Positive or negative? Negative. And the y is going to be positive. Okay, so we're going to convert these. Now, if they're not exact ones, I should know the sine and cosine of 5 pi 6 exactly, but if they're not, you're going to just use your calculator. Just be careful. If they're given to you in radians, you're going to want to be in radian mode, and if they're given to you in degrees, you're going to want to be in degree mode. So, to find x, I would take 3 times the cosine of 5 pi 6. Okay, let's think. Unit circle. What's the cosine of 5 pi 6? Negative root 3 over 2. If I want an approximate, negative 3 times the square root of 3 divided by 2 is approximately negative 2.598. Then y is equal to 3 times the sine of 5 pi 6. So what's the sine of 5 pi 6? 1/2. So 3 times 1/2 is 3/2, which is 1.5. So the rectangular coordinates are negative 3 root 3 over 2, which we said was approximately this, and 3/2. And hopefully if you're looking, that's reasonable, okay? That it's not going to be quite as far as negative 3 because it's been rotated, and then it's going to be up about 1.5. Okay, so that's how we convert things. We should probably do the other way. So let's convert negative 1, negative 5 to polar coordinates. Alright, so what are we going to do? We need to find r and theta. Yep, r squared equals negative 1 squared plus negative 5 squared. 1 plus 25. R squared is 26, which means r is the square root of 26. Okay, so then let's find theta. Let's do it in degrees. Okay, so tan inverse of negative 5 over negative 1. So we do that. And it gives me 79 degrees. If you were to plot negative 5, or negative 1, negative 5, what quadrant would that be in? Yeah. 79 degrees is up here. So are we in the right spot? No. So what should we do to this? Yep. We're going to add 180 so we do get to the right spot. So if you think about it, negative 1, okay. Get to there. So what's 79 plus 180? Yeah, because it's 80 plus 80 would be 260, right? Yeah, 259. Okay, so that's my R, and that's my theta. So if I were to go out about 5 and rotate 259 degrees, you would end up in the same spot as if you were to, in rectangular mode, graph negative 1, negative 5. Does that make sense?